To begin coding the Linear Diner project, the first thing you would want to do is to create a Python program. So we're going to go to MarsCode again. You need to open your MarsCode account. And once you do, you're going to click on Project, and then you're going to select Python again. And the name of this project is going to be called the Linear Diner, so we're going to name it according to the scenario. And once you're done doing that, you're going to click on Create. Once you've clicked on Create, it's going to open for your new project, and this is where we will start to code. Once your program has successfully gotten to load, the next thing you want to do is just get rid of all this code that you have already by default. And then we're going to start coding this Linear Diner. One thing to remember is that the Linear Diner program that we're going to be creating does or is supposed to accept two types of formats of linear equations to be able to solve them. I'm also going to click close the AI assistant, so if you don't need to use the AI assistant for anything, you can just close it, of course. And the format that I'm talking about, the format according to the scenario, the first format that is accepted is an equation, a linear equation that looks like this, where you have the number in the variable first and then a number later on. Then you have an equal sign, and then you have a number coming after. The second format that is accepted is where you have the number first, and then you have the number and the variable next, and then you finally have the number after an equal sign. So these two type of linear equation formats are what are accepted in this Linear Diner that we are going to be creating. So the first thing we want to do is we're going to be creating some variables that we need. We just need actually one to create called expression. You can call it something else. And this variable, what it's going to do is that it's going to be used so that we can check if the person or if the user that wants to use the Linear Diner to solve a simple linear equation is actually entering the correct format of the linear equation that is acceptable for this program. As I've mentioned, there's just two formats in which this system will be able to solve the linear equation. Now, the next thing to do is to create a function that would initiate this program. So the function we're going to start with is I'm going to create this function as main, or you can say main system, whatever you want to call it. So I will just call it main system, or you can say main, anyone's fine. So this is how we create a function. We just use that def keyword and we write the name of the function. The first thing we want to do is to welcome the user to this program and then ask the user to enter their expression. And we're talking about the linear equation expression, so we can be able to check and see if that expression does match any of the two formatted expressions that the system would accept. Now, one thing I would like to do is go to this website where we went to in our previous programming scenario, and we put a very nice ASCII art in the previous one that was called math. Now, I want to put an ASCII art that's probably going to be called algebra. So let's call, or you can put anything you want, really. If you feel algebra is going to be too much, you can put some other type of ASCII art, or you may decide not to. So I'm just going to copy this ASCII art called algebra because I think it's going to add a nice edge to the program. I'm going to copy this ASCII art, and you can do something else, or you can decide to omit this. Just before I ask them to enter the expression, I just want to paste this ASCII art. So I'm going to do it again. It seems like it didn't copy for me properly. So I'm going to copy it. And then I'm going to come here and paste it, and there it is. So just look at how it actually looks like so that you can arrange these symbols. I'm using the font Banner because I just like using this font. It just gives the whole, it makes it look good. It just makes the whole ASCII art look better for me. So this is the ASCII art saying algebra. I actually want to print this in a specific color, as I always do. So I'm going to print in the beginning a color code. An ANSI escape color code, and I'm just going to take this format and then copy and then of course paste it in here. And remember how the color works is that you just have to put the number of the color you wish from the color code table depending on what color you want. So for this algebra ASCII art, I think I'm going to go with a color that's a little bit brighter. I'm going to go with 13. So it's like a dark, sort of like a magenta, dark magenta. So I'm going to write 13 here, and then I'm just going to print each line. Remember that if you want to put ASCII art, you have to print each line as you go. So I'm going to be printing each line right now, and you have, of course, to align these statements inside of your function because that's the proper indentation. Of course, if it doesn't look like the ASCII art at the end, you can then adjust it and, get it to look like the ASCII art you want it to be. So right now, I'm just printing every single line of this ASCII art to get it to work. And then, one more thing I would like to do, I forgot to mention, just before we created this expression variable, is I would like to import the time library because I feel I'm going to add those like time pauses between statements. So remember what that time library does. So please make sure you go up and import time library if you want to create like time pauses between your statements. And then here again, I'm opening up my parenthesis and I'm just basically putting my ASCII art as well. And then, of course, I'm going to space this in. You can use your tab space or tab key on your keyboard. And then close this one at the very end here as well. And, of course, space this one in. And, of course, this line as well, print, and then open parenthesis and close it here at the end. And then, of course, space it in as well. And then finally, I'm going to print this as well, open parenthesis, quotation mark, and quotation mark as well, and close parenthesis. So this is kind of how my ASCII art is looking. It doesn't look exactly like how it's supposed to look. So that's why I said you need to arrange it, obviously. So what really happens is that this moves one place forward, and then this one kind of moves one place forward as well, sort of creating like that A shape, which it should be creating. And I feel like some of these ones have to go a little bit in. There's like a difference of a space. They kind of all align, and what really just doesn't look good was that asterisk there that was not looking good. So I think everything does look normal now. It looks like there's an A, there's an L, there's a G, E, V, R, A, so it does look good. And of course, if you want to test this just to see how it looks so far, you can call your function at the very end, mean system, make sure it is on the same line as where you define the function if you're calling your function. And of course, you can do a Command S or a Control S, or you can go here and save because you have to save it before you run. And then just click on the run so that the compiler can run this program and you can see the result. I think it looks perfect. So that's what I wanted. It does write algebra. Now I'm going to continue. Now that you've confirmed, I'm going to print, or before I do any print, I'm going to wait for about a second. So I'm using that time module or library that I've imported. And then I'm going to print another color here. And what I'm going to do for this one is I will print, let me copy this color code again. And I want to do a different color where I now ask the user to enter the expression that they would like to use or they would like to be solved, the linear equation expression. So I'm going to go with the color of red. I'm going to use 9 here. So that means I'm going to take out this part and then just put 9. And then I'm going to print a nice ASCII art over here that kind of just like creates a, a division, or should I say separation or a demarcation between the statement previous and the statement coming up next. Now I'm going to ask the user to enter the expression. So this is what I'm going to do. Remember, we created that variable expression and we global the variable, by the way. We still have to global this variable. So when you create a variable outside of your function, you have to make sure you global the variable if you actually want to use it. So I'm going to global this variable expression, global expression. And then here I'm going to create another variable called expression1, and I'm going to be asking the user to enter their expression. So I'm going to say string input, and I'm going to say enter your linear expression. Enter. Oh, and one more thing. Because this is a diner, the theme of this whole program is a diner sort of theme. We're going to act like you're entering a diner, and then, of course, the first thing you do is you're given the menu, and then you're asked to choose what you want. So what we'll do is we'll print just before we ask them to enter or choose the linear expression format they would like to solve. We're going to do something like this, guys. So we're going to print here, and then I'm going to go with, going to say the linear diner menu. Okay, so we can do welcome to the linear diner. That's the first thing I'll do. And then I will come down here and do a time.sleep. So you notice that I've just gone up one, a couple of lines just before this expression1, and I started adding some extra things in here. So I'm saying welcome to the linear diner. I'm going to come down here and I'm going to say print, here is our menu. This is what we have to offer. So that's what this is what we have today. How can I help you? So that kind of a thing. So I'm gonna do print. I'm gonna also do a different color code. I think for this one, I might go with a different color. I just like colors. So by now you should be able to know that I like the change of colors every time. It just makes the console look more lively, I feel. But you don't have to change colors. You can just decide to keep one color. I think I'm going to go with 81 for this one, for this color where I print out the menu sort of. So I'm going to say, so basically we'll give you the first option, we'll say solve format. So we're going to do something, actually before that, I'm going to do something like menu, right? Just show them what menu we have available. And then I'm just going to come down here and do the menu as print. And then of course, I'll just write down number 1, or you can say, yeah, you can do number 1, which is easier. What we have the menu where you can solve equations that are like 2s plus 76 equals 100. Oh no, we can't do 3 digits. It's only 2 digits according to our scenario. So I'm going to go with, perhaps we can say, equals 89. You can write anything there. This is just from the top of my head. And then print the second type of equation format that is acceptable to be solved in this system is something like 87 plus 4t equal 99, for example, right? Because it's 2 digits, so a total of 8. And including the symbols, of course. We can do subtraction here because this system also does accept either addition or subtraction as the operator. And then we're going to say, what would you like to have? So before we do that, I want to print a nice ASCII art here. And I kind of want to follow the same step of the ASCII art that I have on line 20. So I'm going to do something like this. I'm just going to put in a nice ASCII art. And then I'm going to come down here, and this is the part where I go time.sleep and wait for like 1 second and ask the user which, I'm going to say which equation would you like to solve? And then, of course, tell them how they respond. So you can say 1 or 2. Okay, this is really important. And this is where you do that data validation as well, and you check to see that they're actually entering 1 or 2. And then you have to also check if the expression they're entering is the right expression, where they have either the number and the variable in the beginning, or they just have the number in the beginning. So you got to check that it does match this type of expression, because you don't want to accept something incorrect in your system, which is not going to work efficiently. So what we'll do just before we do the whole checking to see if the expression is is the right format or not, let's do the validation where we actually check and see if they actually enter 1 or 2. So we're going to say while expression 1, we've used this in our previous scenario, we've done this type of validation where we check to see if they've actually entered what is right or not. So if they enter an expression that is not 1 or 2, that's why I said while expression not in 1 or 2, because we give them only 1 or 2 as their option. We're going to tell them invalid input, and I'm using the AI assistant on MarsCode, which is brilliant because it just helps you when you have code that you need to repeat, especially in this situation. And so I just use the AI assistant to help me print out the same thing that I would need to do, which is, of course, tell them invalid input, and then, of course, afterwards give them the opportunity to enter the expression again. So what I would like to do, though, just one thing before I print that invalid input, is I would like to print it in a different color. Actually, I would like to go with a red color, because this is sort of like a warning symbol. So I'm just going to copy this ANSI escape color code, and I'm going to paste it over here. This is for red, by the way, so red color. And that's just going to say invalid input. I'll put an exclamation, just add a little to that. And then, of course, give them the opportunity to enter the expression again. To enter the option again, whether 1 or 2. Now I'm going to say if expression is equal, and now we're going to do another thing. Once we've done that check and they've actually passed the first check, which is they've entered 1 or 2, the system's going to do a second check, which is to now see if the expression they're entering goes with any of these 2 formats, like if it matches any of the 2. So what we're going to do is we're going to create a variable called check expression. And this variable, we're going to use this len method to find the length of the expression they're entering. And so one thing to tell them, though, which I forgot to mention, is to tell them to enter the expression without spacing. Okay, this is very important. So give them that instruction. Tell them, please enter the expression without spacing. This is very, very essential so they know they don't need to space. Because when you space, then the length of the expression is not going to come out as 8. Right? It's not going to come out as 8 because here you have 2 plus 1, which is 3, and then plus 2, which is going to give you 5, and then you have plus 1, which is 6, and then plus 2, which is again 8. So that's why I said the length of the expression should come out as 8. That's what we're looking for it to do. So you have to tell them to please enter the expression without spacing. So one thing you could do here is put a simple instruction, and then I'm going to put it just before expression 1, and we'll put an instruction here and say, please enter the expression without spacing. And so for this one, I'm going to use a different color code again. So I'll copy this color code thing. And just because I want to give a different message, I'll go with 172 here. So I'll go do a /n because I want to go to the next line, paste this color code format, and write my color that I want, which is 172. And then I'm going to print that message saying, please enter the expression without spaces. So I'll say, please. Oh, actually, guys, this should have been done where we shouldn't do this here. I'm going to take it out. We're not going to do this here. Because here is where we ask them to choose the expression first. Then if they get it correct, we're going to ask them to enter the expression. So that's something that we missed actually. So we're going to create a variable here where we ask them to enter the expression. So it is here that we're going to ask them to enter the expression without spaces. Okay. So we're going to say, please enter. So I didn't put the code block, as I was saying at the top here, I brought it down here. After they choose 1 or 2, because they're going to select which expression they want, whether it's the first or the second, both of them are a total of 8, the length without spacing. Okay, imagining what I mean without spacing is like, imagine the expression looks like this. There's no spacing, so the spacing does add an extra count for the length of the expression. So if they enter something like that without spacing, it will return a length of the expression as 8. So that's how we know they're entering the correct expression. Of course, we're going to check with things like symbols and stuff. Are they in the right places and all of that? So right now, we are giving them a 1-second pause, and then afterwards, we're telling them, please enter the expression without spacing. Okay? So that note is really, really important so that they know. And then we finally, I'm going to print like a nice ASCII art over here. So this is where you're going to put it. And then you have to create a variable that's going to be reading the expression. So I will create a variable, and I will not call it expression 1. We have to make it different from expression 1, because expression 1 was where it was just checking to see, giving them the opportunity to enter 1 or 2. I'll call this one expression 2. Okay, so expression 2 is where they would enter the expression. So here will be string input. The expression would be of a string data type because it's like alphanumeric. So here we're going to say enter the expression. And then once we do that, of course, give a space. Now we can do this check expression variable, and we can now find the length of the second expression that they're entering. So that's kind of what's happening. So once they enter the expression, of course, I would like to put my ASCII art. Everything I'm doing here is just to make the aesthetic of the console look better. So if you see me putting ASCII art, a color, it's just to make things look better on the console. And of course, you can decide to omit that and go straight to the solution itself. So now that we have this check expression variable that's finding the length of the expression, the next thing we're going to do is to check if the length of this expression is equals to 8. So we're going to say, if it is not equals to 8, that means the length after they've entered the expression without spacing, it's not 8. We're going to tell them, sorry, this is an invalid expression, and then we're going to give them the opportunity to enter again. So that's why we said we have to check. If, however, they enter an expression that is equal to 8 in length, then now they can proceed to the main functionality of this program, which is to solve their linear equation. So what we're going to do is we're going to say while check expression, which is the variable that finds out the length of the expression they entered, is not equal to 8. So we're using the while loop again for this data validation. Then we're going to print this again, color saying invalid input. So I'm going to use the AI assistant to do that. And it's going to give them the chance to enter the expression again. So that's how the while loop works. You have to tell them it's invalid, but then at the same time, you have to give them the opportunity to re-enter the expression and then to check the length of the expression again and go back again and check if it is still not equal to 8 or if it is equal to 8, and they can proceed. So right now, we have given them the opportunity to enter the expression again. And now we're going to come down here and say, okay, well, if the check expression is equal to 8, which is correct, that's what we want. If the length is 8, however, we're still going to check it. It doesn't mean just because it's 8, it is correct. You still have to make sure that the symbols are in place, the numbers are supposed to be where they are according to the format of what the system can solve. So here we are going to print a message and we're going to say valid expression. So I want to use emoji a little. I want to use an emoji like a check mark emoji, and I'm going to look for a check mark emoji. And I'm going to see which one I can use because I want to say like valid and I want to use a check mark emoji. And when you say invalid, you can use like an exclamation sort of warning sign emoji. That just adds more to the aesthetics of the program. So I'm going to go and copy my color code and I want to say valid expression and I want to use green for this one. So I'm going to use 40 for this as the color code. So I'm going to change this, remove that and replace it with the number. S40, of course. So here I'm going to print the message and say valid expression or expression is valid. And yeah, and then you can, call the function. I'm going to take out that part. And this part is where I want to put this nice emoji. You may decide not to include this, but I just want to add to that aesthetics to make it look good. Now I'm going to use that variable that we created outside of the function. If you guys remembered, it's expression. And I'm going to use that variable to assign it to this valid expression called expression2. Because we're going to be using this expression2 to be able to solve the linear equation that the user has entered. So that's the reason you have to assign it to a new variable, so that the compiler recognizes that this is assigned to this, can be used anywhere in your program. Now we're going to create, but we're going to put the name of the function, which we're going to create another function that will be responsible for solving the linear expression. So we're going to call this function solving expression, okay? And put a circular bracket. So this is how you call the function. We don't have this function, which is why you see this yellow line saying that it's not defined. We have to go back and call this function, create this function. So we're going to go to the top here, right after this expression, just before the main system. Let's create our function at the top here. So the function we just called right now is called solving expression. So we're going to create it right here. Inside of this function, it is important that you global the expression. Oh, actually, you don't need to global the expression here. I kind of misthought that. It shouldn't be globaled in your main system. No, it should actually, because you still need it to be able to assign it to this expression too. So you still need to global it so the computer knows where you're getting expression from. So you globaled it in here, and now you're going to global it inside of this new function called solving expressions. So here you're going to global expression as well. So I'm going to global expression variable because that's the one that you've used to assign if the expression is actually correct. So you have to global it so the computer can recognize what you're talking about when you say expression2. You notice we no longer have a yellow line here because we've now created this function called solving expressions. Now in this function, this is where we're going to start the functionality of this program to actually solve the linear expression. But I would definitely suggest that at this point you run your program just to see how everything is looking like and is working before we proceed into the solving expression function. So what I'm going to do is I'm going to click on run. So you can kill this run right here on your terminal and then just click on run so it runs again and you can see how it works. But make sure you save it. I already did a command save or command S or control S. As you can see, this is how it looks like so far. If I enter something that's not right, it would say invalid input because I put 3 and we have only 1 or 2. But if I enter 2, for example, it would accept it and it will ask me to enter my expression. And this is kind of where we are. So if I enter an expression, for example, 3t or 3r, and then I say minus, maybe I say 56, and then I say equal to, if I entered something that was wrong, for example, if it wasn't right, like I entered it with space, 3r minus 56, even though this expression is the one that the system does accept, but because there's spacing, it's not going to return a length of 8. You can see it says invalid input. But when I do enter an expression without spacing, and I say 3r minus 56, but there's no spacing this time, equal to 78, the exact same expression, it should be returning to me as expression is valid. You see that? It returns expression is valid because it does count the length of the expression, and it is 8, so it is valid. So this is where we are so far in our program. So since everything's running fine up until there, we're now going to go back to the solving expression function, which is where we actually start solving this linear equation that they've entered. Now, the next thing we want to do is we're going to create a list, 2 lists actually. We're going to create a list that would accept the symbols that we are going to use to solve their expression. The symbols accepted for the system, as given in the scenario, is the plus and minus symbols. So I'm putting a list, and we already learned how to create lists. You basically just have to write the name of your list, equal, and square brackets, and then put what you have in your list. So I put a plus and a minus sign. I'm also going to create a list that accepts numbers as well. So what kind of numbers are going to be accepted for the expression they're entering? So we know that everything has to be a 2-digit except the symbol, of course. I'm talking about like everything in terms of like the number, or in terms of the number in the variable, and in terms of the number again after the equal sign. So they all have to be 2 digits. So therefore, in the numbers list, we can only go from 1 to 9, not including 10. If you want to extend this program and make it accept like 3-digit numbers, because maybe you want to put something like 145, for example, I mean, you want the system to be able to solve that as well, then you can go further and add all the way from 10 to 28. It really just depends. You're just going to have to extend it to that matter. So I'm going to use the AI assistant to get all my numbers in. I'm going to take out the 0 because we don't need the 0. And all the way from 1 to 9. So basically going from, because it's going to accept numbers, so it's going to be checking these numbers, it all goes, whatever these numbers are, the maximum would be like 99 because it all goes all the way to 9. So it's still going to be 2-digit. Now, we're going to be creating some variables. We're going to create expression 1. I'm going to make it short because we're going to need these variables so that we can go through the expression that the user is entering, and we can save each of these expressions in this linear equation separately to a variable, and that's the variable that we're creating here, so we can be able to make the system solve the expression properly. So we're going to create all the way to expression 4. Each one of them would have their own functionality, which you're going to see. So we're going to create expression 3 and of course expression 4 as well. And then we're also going to create another variable for the symbol. And when we talk about the symbol, we're referring to the plus or minus. And that also is, equal to nothing. So when we do this in programming, we call this declaration and initialization. You're basically declaring the variable and you're also initializing it to nothing at the beginning. So it's like an empty string. Now we're going to create something called a divider, which we're going to set to 0, and you're going to see what we're going to use it for. This one is set to a number. It's not set to a string. We're going to use it for calculation. Then we're going to be creating 2 Boolean expressions. Check 1, which we're going to set initially to false. It's like a flag, what we call it in programming as well. And then check 2 is equal to false. And you're going to see how we're going to use them. These checks are going to be very useful for us when we're trying to determine what sort of expression the user is entering. Did the user enter an expression whereby the number and the variable is coming first, or did the user enter an expression where the digits are coming first? So that's going to be very relevant in that case. Now, afterwards, we're going to create another variable called the letter, and this one's going to be very useful for like what kind of letter is next to the number for the number letter expression. So this one's going to be set equal to 0. Then we're going to be creating a count, which we're going to use to count when going through, and you're going to see. Now we're going to start. So the first thing we're going to do is we're going to go through the expression. That means whatever they've entered as the expression, and we're going to split this expression. So how we're going to split it is we're going to have one part as expression 1 or exp1, so like the 2x for example. We're going to have one part as a symbol. We're going to have one part as the expression 2, like 45, and then we're going to have one part as expression 3, like the equal sign, and then one part as expression 4, which is like the number after the equal sign. So that makes sense. So that's kind of how we're going to split it, so we can be able to tell the compiler that when you're solving something like this, where there is a plus sign, for example, then this number has to move all the way to the other side. And of course, it now becomes 2x equals to 89 minus 45 because the positive moves across the equal sign and changes the sign to a negative. And so now it becomes 2x equals to 89. So we're basically trying to do this part. I'm just going to show you. We're trying to do it so that it looks like this in the end, okay? In the end, it's going to look like this. It's going to be 2x, and it's going to be equal to 89 minus 45, which then solves to its final solution. So that's kind of what we're trying to do, okay? That's what we're trying to do in this next part that we're going to be doing. So we have to split these expressions. So the first thing we're going to do is we're going to use a for loop. I'm just going to say for a in expression. Remember that we global this variable expression, and remember that this variable expression was actually storing the correct expression that they were entering depending on whatever format they entered. So we're going through every single thing in this expression, starting at the beginning, each and every single one. So this does not count as one, guys, like you know that, oh, this is one expression. No, it counts, these are going to be separated. This is starting at 2, which is 0. Remember that the computer starts to count at 0. So it will have an index position. 2 has an index position of 0. X has an index position of 1. And then remember there's no spacing, so we don't have any spacing. That means that plus has an index position of 2, and then 4 has an index position of 3, and it just continues in that way. Of course, because we have an expression without spacing, so we're not counting spaces as index positions. So that's what we're going to do. We're going to determine the index position so we know how to break down this expression so it looks like this. So the first thing, as I was saying, is that we'll do the for loop, and for a in expression, we're going to first check the symbols. So we're going to say if a in symbols, right, we have the symbols list. We check to know what kind of symbol they're having in this expression, whether it's a plus or minus, because that's what we accept, or that's what the system accepts. Then we're going to create a variable called index so we can find the index position of the expression, of the symbol, sorry. So if it is a plus or a minus, it doesn't matter. We're going to find what position it is at. Because when we find what position it is at, we can be able to break down to get this expression, and we can break down to get this expression. So for example, I'm going to give you an example. Okay, let's work with index positions now and try to pay attention to what happens. So index positions in lists. And this is applicable to all programming language. It's just how it works. In some programming language, of course, you have lists, and others you have arrays. Now here, what we're trying to say is if we have this expression as 2x plus 45 equals to 89, right? Now let's assume there's no spacing. This is all together because let's not assume. We know there's no spacing because we have the validation checking to see that the length of this expression is 8. Now, we know that the 2 starts at an index position of 0. Remember what we talked about, guys. So this is basically the for loop. What it does is that it splits everything like that, and it just splits everything. So here, 2 is at index position of 0, x is at index position of 1, and then we have the plus sign, which is at index position of 2. Then we have the 4, which is an index position of 3. And then 5, which is in an index position of 4. And then we have the equal sign, which is in an index position of 5. So it's basically that way. It goes in that format. So it's basically a total of 8. But because it starts to count from 0 and ends up at 7, it looks like it's 7, but it's not. It's 8. So all of these things in the expression have their own positions. And that's how we're going to know when we know the index of the symbol, then we can be able to use this expression, which is like a string or what we call like a joiner, to join the things, the expression that's just before the symbol and the expression that's just after the symbol and the one that's after also the equal sign as well. So we can be able to know how we can break it down for the compiler to solve. So what we're going to do now is we'll say index equal, and then we basically are going to find the index position of the symbol, and then we're going to say expression dot index of the symbol, which obviously is the A, because we said if A, that means as you're going through this expression, if you do find the symbol, which is the A one or the A letter, then we want to find the index position of that symbol. And so this is going to return for us 2, of course, because that's the index position. That's where it's placed at. So it will return 2, and with that index position, we can do -1 to get the one before, which is x, and then -1, or you can say -2 again to get the one before x, which is 2, and combine them together and get our first expression as 2x. So essentially, this would break down to expression 1 would be equal to 2x by the time we get the index position of our symbol, and then we do a -1 and the -2. So then expression 1 would break down to 2x, and then symbol, obviously, we remember we created that variable, would be equal to plus or minus, depending on what they enter. And then, of course, expression 2 would be equal to what expression it is, and that's going to be, again, by knowing the index position here, if we do a +1, that's going to give us, so 2 plus 1 is 3, so you can see that would be the index position of 4, and then we do a +2, and that's going to give us 2 plus 2, which is 4. So it gives us the index position 4, which is 5. So we combine this together using this joiner expression 2. And so expression 2 would be that 45. And then expression 3 would be that equal sign. And then expression 4 would be the number after the equal sign, which is 89. So that's kind of how we're going to break down this whole expression using index positions and lists. So we can be able to make the compiler it's going to run this program to solve the equation. So right now, we got the expression, the index position for the symbol, and we're going to move on to the next thing, which is where I said we're going to be getting the first expression by doing from this expression -1 and -2 for the index positions. So we can be able to get these two parts of the expression and combine them together using this expression 1 joiner. That's why we created it. It's like a string joiner. It's used to join them. Because when you do -1, you're getting x. When you do -2, you're getting 2. So if you add them, join them together with this string joiner, you're going to get that expression 1 as 2x. So that's what we're going to do here.